Hello, I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this particular video, we have adopted a very simple approach that is for beginners to understand what an ellipse is. How do we model it and how do we find the parameters of ellipse? Mainly, how do we find center, axis of symmetry, foci and the vertices from the given equation of an ellipse? But before we get into that, we'll also have a visual look at what exactly the ellipse look like and what happens when we change the parameters of the ellipse. It expands, it contracts, it moves. Why? And then we'll mathematically model it. So we'll begin with the common understanding of an ellipse. Have a look on the visual representation. Mathematically model this ellipse. We'll talk about the foundation for modeling. Once you've done that, we'll take up the standard equation of ellipse, which will now be considered as a general when we adopt transformations in it. So the general equation is given to you as shown here. From the general equation, we will find these critical parameters. We'll also kind of do the reverse thing. From the parameters, find the equation. You understand? And of course, given the equation, we will sketch. So in all, it is complete in itself. We'll have 4 examples to understand all these. With the help of these examples, we will understand how do we explore the graph of an ellipse and how do we explore the equation of an ellipse. And that will give us a very good foundation to really master all about ellipse. Sounds good? So let's begin with the common understanding of what an ellipse is. Well, as shown here, you all realize that if a cone is sliced, as shown here, obliquely, then the shape which you get is that of an ellipse. Do you see this? So that is what we call an ellipse. Now, why I have given some restrictions to this slice? Let us read through the definition itself. It says ellipse is formed when a cone is cut by an oblique plane which does not intersect the base. Well, our base is the top portion of this cone at present. It could be kept the other way so that it can stand, so that becomes the base. You get the idea, right? So the whole thing is, why are we not slicing? What happens when we slice it from, let us say, this side? Then what shape do you get? Or if it is not oblique, if I kind of slice it like this, then what happens? Explore these ideas. Well, as you can guess from the ellipse itself, if I slice this in this case from the top, then we'll get kind of half of this ellipse. You see that? The other half comes from the other side. So as you can see here, what we could get from here is a parabola. Do you see that parabola shape? So it will be kind of like this. So I can say it will be kind of like this. Do you see this? So that becomes a parabola. So if I slice like this, what we get is a parabola. If I go straight, not oblique, horizontal, in that case, what do we get? We get a circle as shown here. this is also a slice from the top, which is horizontal. So basically, what we're trying to see here is that a cone is having one axis. So this is the axis of cone. So it has to be at an angle. So let's call this angle as theta, oblique to the axis. You get the idea. If it is perpendicular, as shown here, then what you get is a circle. And if crosses through the top in this particular case, right, as you can see here, we get a parabola. We'll explore what happens if I slice it from the top and which is parallel to the axis. So if I slice in this direction, what really happens? What kind of shape do I get? So that is for you to explore. So in explore section, we have these parameters for you. How a circle, parabola, and hyperbola can be formed from a cone. And as you all know, and you've seen my earlier series, that ellipse is a conic section. All the shapes which I'm talking about, including the hyperbola, are conic sections. It depends how do you slice the cone and then get the shape. And this shape, the 2D shape, is what we are talking about. And this shape is ellipse if you're slicing it at an angle which does not intersect the base. You get the idea, right? So that is what an ellipse is. Now, with this idea of ellipse, let's have a visual look on how does this graph of ellipse look like. Let us have a visual on the ellipse. The X shape in green color is called an ellipse. It has two axes. One is horizontal and the other one is vertical. Since the horizontal is longer, we call it a major axis in this case, and the other one is called minor axis. The 2 points where the curve crosses the major axis are called the vertices, and the points where the curve crosses the minor axis is called co-vertices. We do have two focal points also. These are the points which will actually define an ellipse. We will see how. Well, one thing very interesting, if if there is a ray of light, it will get focused at the particular point which gives its name focus. It's like a parabola, right? So those are the two focal points. We will see that this ellipse can be translated to different positions. The position at present is with center at the origin. This is called the standard position, and that gives us the standard equation of an ellipse, which is x square over a square plus y square over b square equals to 1. A is the length from center to the vertex and b is the length from center to co-vertex. Let us now look at the translation of an ellipse. If the value of h is changed, then it moves horizontally as shown here. The points along the major axis, which is horizontal, also move with the same value. Focus, vertex, equation of the directrix all change with change in h value. Similarly, we can have the movement in the vertical direction. in this case, as you can see, the translation is in the y value. The x value for all the key parameters will remain same. We could have the combination. So that gives us the transformational equations of an ellipse, which we are going to look into. We'll have examples on standard as well as transformational equation of an ellipse. To model an equation for the ellipse, we use one of these two concepts. One way to define all the points on the ellipse is to say that the locus of points is such that the sum of distance from the two focal points is always constant. As shown here, the sum of distance for the point in purple from focus on the left and from the right, if you add that up, is also equal for the point which is shown in orange. And it is true for all the points on the curve itself. So that gives you a formula to work with, and that results into the equation of an ellipse. The locus of points on an ellipse can also be defined as the ratio of distance from the focus to that from the line which is called directrix. So this ratio of any point on the curve from the fixed point called focus to the fixed line called the directrix is called eccentricity of an ellipse. It is always less than 1. That helps us to give all the related equations for an ellipse to work with. We'll have many examples to practice with the equation of lines and find or relate the parameters. So I hope you enjoyed this presentation. We'll get back to our examples to sort some values and work with the equations which we have derived from these concepts. I hope you enjoyed the visual look and feel of the ellipse. It is very interesting to see how the shape of the ellipse changes when we change different parameters. We will now learn how to model it and represent it in the form of an equation. We call this process as mathematical model. So there are two ways in which we look at the ellipse while defining a mathematical model. One of them is it is supposed to be a locus of points in a plane such that the sum of its distance from two other points called foci is constant. As illustrated in this particular diagram, we have an ellipse, and what we are trying to show here is this sum of distance from a point on the ellipse is same distance from two fixed points. Now these are called the two foci, singular focus. So any point will give you these characteristics as shown here. So if I take a point on this side, even then, the sum of these distances is same. And using the distance formula, we can come to the equation of an ellipse. The 2 points which we are talking about are called the focal points, right? So this is the focus of an ellipse. To understand focus itself is kind of like this. If you look at one half of the ellipse, let us say the left side, think about a lens, right? So let us say this is the lens. All the light rays which will kind of come like this, let us say, will actually go through a point. So they'll be reflected from this this parabola, right? So they'll be reflected from the parabola, and after getting reflected, what you see is that they will actually concentrate at the focus, and that could happen from either side. So correctly, this is the name given since the lines which hit the curve on the end will focus at a particular point, just as we saw in parabolas, right? And if you look at it very carefully, each half of this ellipse do look like a parabola, right? So that is the concept. So from here, if you equate the distance of any point P, which is considered as xy, with focus, we'll call this as focus on the right side, and we'll call this as the focal point on the left side. Then the sum of these distances is always constant. So that gives you a mathematical model, and that is one way to approach this particular model. The second way is that, as defined in all the conic sections which we learned earlier, we know that ellipse is a conic section. So in this conic section, what we notice is that locus of points in a plane that move in such a way that the ratio of the distance from a fixed point focus to its distance from a fixed line directrix is always constant and is less than 1. So now we are talking about the distances of a point from focus to the distance from a fixed line. Now these lines which are shown here, the vertical line in this particular case, are called directrix. So that ratio is constant. So what we are trying to say here is, if this point P, and that is the focus F, distance from the directrix is measured perpendicular, and let's say PM is that particular distance. In that case, the ratio PF, which is point to focal, divided by from point to the line, the fixed vertical line directrix, is constant, and this constant is E for all the conic sections. Correct? Now, if E is less than 1, in that case, what we get is an ellipse. So this is a very important property, and it holds good for all the points. So if you take up this point, for example, here, then we will consider these two distances. You get the idea, right? So let's say this is P dash, this is F dash, and this is M dash. Then these ratios will be constant. You get the idea. And it is E. And of course, it has to be greater than 0, right? So it is between 0 and 1 to get an ellipse. So you have to think about what shape will it be when it is greater than 1. Correct. Okay. So whatever you do, whichever way you work out, you get one equation for an ellipse in the standard form. So in the standard form, what do we say? This equation we say is in the standard form. Standard form means the ellipse which we have shown here and as also described in the visual presentation is when the center is at the origin. Correct? So this is an ellipse which is wider along the x-axis horizontally, right? And the other axis is smaller. The two axes, as we had also discussed in the visual, they're called the major and the minor axis, right? So this axis is called the major axis, and this axis here is the minor axis. Okay? So these are the two axes which we are talking about. In this equation, x square over a square plus y square over b square equals to 1. As shown here, we will notice that the value of a is greater than b. So if it is horizontal, if the major axis is horizontal, in that case, a will be greater than b. But if it is the other way, in that case, b will be greater than a. Correct? We'll get into these details also. But I hope you have understood the concept, the base to model an ellipse, right? So the distance formula, distance from a point P to the focal, and distance from a point P to the line called directrix. That ratio is E, and that helps us to get this equation, which is true for any ellipse whose center is at the origin. Perfect. Now let us explore the standard equation of an ellipse. The standard equation is x square over a square plus y square over b square is equal to 1. And when we say standard equation, the ellipse has center at the origin as shown in this particular figure. So at this time, the center is C, which is at 0, 0. Let us find the x and y intercepts. How will you find the x-intercept? Let's look into this part. How do you find the x-intercept? Well, to find x-intercept, I will put y equals to 0. So the equation was x square over a square plus y square over b square equals to 1. If I put y equals to 0, I get x square over a square, which is plus 0 here, equals to 1. And that gives you x square equals to a square. So what could be the values for so what could be the values for x-intercept? Well, let's do square root both sides. So when we do square roots, we get absolute value of a, which is plus and minus a. So we get these 2 points, which are the intersection of the ellipse with the x-axis. Now these 2 points are called vertices. So one on the right, I'm referring to as vertex as the right and that one on the left side. Now the distance between these two vertices is called the major axis, right? So we have a major axis along this, and since it is plus and minus a, the length is how much? Well, the length is 2a, right? And it is a horizontal axis along the x-axis. Therefore, the equation will be what? The equation will be y equals to 0. So I hope you understand all this. And it is summarized here. The x-intercept, which we get from the formula itself, is at x equals to plus minus a. And what we get is vertex. Two of them, one is at plus a, the other one is at minus a, coordinates being plus minus a is 0. The y value, of course, is 0 for the x-intercept. So that is how we get these two very critical points, beginning from the equation of ellipse with center at the origin itself. You can do the similar calculations and find the y-intercept, right? So for y-intercept, what will you do? For y-intercept, you will place x equals to 0, and once you do that, you get y square equals to b square. And therefore, there are 2 points on the y-axis where the graph of an ellipse intersects, and these 2 points are called co-vertices, right? So they are called the co-vertices as given here. So co-vertices are the y-intercepts when an ellipse with center at O is drawn. So these values are plus and minus b, which can be written as a coordinate point 0 plus and minus b. The axis, major axis, is, as we said earlier, along the x-axis whose equation is y equals to 0, and the length of the major axis is 2a. The minor axis is vertical in this particular case, and the length is 2b. It is vertical since a is greater than b. Major axis is longer than the minor axis. Now, how do we find the focal points? F, the focus. For that, we'll derive a formula in another video. Here, we are keeping things simple and straightforward. So, the distance which gives us the focus is now defined as c, or in terms of the eccentricity. Remember, we said that the ratio of the distances is constant. That constant E is called eccentricity. So that ratio gives us the focal point itself. So the focus has a coordinate point which is plus and minus AE, and it is always along the major axis. So what we'll notice here is that the center, the vertex, and the focus, they all lie on the major axis. The formula which we have in this model help us to find all these points very easily. You don't really have to remember them. But see here, we know A and B from the equation itself, or if I am given the graph, I can see the distance between the two vertices, divide them by 2, will get A. So as you can see here, A is from origin to the vertex V, right? And these two distances from the symmetry are equal. So 2A is the total length, correct, of the major axis. Half of that gives us the value of A. Similarly, we can find the value of B, half of the width or the minor axis. The difference between the squares of these two gives us a value of C, and that is the coordinate point for the focus. So plus minus C, 0. So measuring from center is kind of easier, and therefore the term C has been introduced here. So plus minus C from the center is what gives you the focal point. So that is shown as the focal point, which is C units from the center. And how do we calculate C? C is calculated as square root of A square minus B square. That means difference of their denominators, square root. Perfect. So difference of their denominators, if you do, then you get the value of C square, and when you square root it, you get the value of C, or the distance of focal point from the origin. Get the idea, right? As I was saying, eccentricity is the basic definition of ellipse, the ratio of the distance from any point to the focal point and to the line. That ratio is E, which you can see very clearly, and that ratio works out to be 1 over A times A square minus B square, or in terms of C we can write it very easily as C over A, right? C over A. And equation of this directrix is given as x equals to A over E. So this equation of directrix is x equals to A over E. Now this is on the left side, therefore minus A, and this will be x equals to plus A over E. So that is how you get all the parameters of an ellipse using the simple equation where the center is at the origin. Now you are given an ellipse here whose equation is x square over 4 square plus y square over 3 square equals to 1. I would like you to find the focal point and the equation of directrix from this particular equation, right? So you can work on this. So from the equation given to you, let me just highlight this equation here. X square over 4 square, which is 16, plus y square over 3 square, which is 9, is equal to 1. Try to find the center. You know it is at origin, the vertex, and the focal points, the foci, correct? Length of the major and the minor axis, and you can also find the equation of the directrix, these lines, using the given formula. Take your time to do it, and here I will show you how to calculate these values very easily. So what I've done now here is shown you the ellipse which we used to model, correct? So as you can see, the ellipse is wider along the x-axis. Since it is wider along the x-axis, you do understand that the major axis is along the x-axis, right? Well, this time what we are doing here in the example is we have taken an equation. The equation is x square over 16 plus y square over 9 equals to 1. From the equation, we want to find all the parameters and then sketch, right? So the idea is to identify center, vertices, co-vertices, and foci of the given equation. And once we have this, after that we'll graph. Is that clear to you? That is the way in which we are looking at it. Perfect. Center clearly is 0, 0. This is the standard form. And here, the denominator 16 can be written as 4 square, and therefore A is equals to 4, and the other denominator 9 is equals to 3 square, and therefore B is equals to 3. We know that now. Immediately after, we can find what c square is, or c is. C is square root of difference of these, right? So 16 minus 9, 4 square minus 3 square. And we get the value of c, which is equal to, as shown here, 16 minus 9 gives you the value 7. So square root of 7 is the value of c. Once you find value of c, you can find all the points. Well, clearly, the vertices are a units apart, right? Vertices are always along the major axis. So important thing to note here is that the points, vertices, the focal points, two of them, two vertices, they will lie along the x-axis, correct? So vertices are a distance away, 4 units away, correct? Therefore, the vertices which we get are at plus and minus 4 as shown here. So we know the center is at 0, A and B values are 4 and 3 as calculated here. And the co-vertices are the B values, right? So those are the co-vertices which are at plus and minus 3. We calculate the value of C by finding the difference of the denominators and then square rooting, which is square root of 7. And that gives us the foci, which is at plus square root 7 and minus square root 7 along the major axis. Correct? So now the question for you is find equation of directrix. Correct? So that is left for you. You need to first find what is the value of E, right? So first you find what is the value of E, and then you find what is this horizontal line, directrix. As you may remember, the formula are given right here, correct? So you need to find the value of E and then the value of X. E is given as, this is C, right? C over A. So E is C over A, right? So let me write down here. E is equal to C over A, and the value of x's is plus or minus. There are two of them, correct? And E is always less than 1. Remember this, E is always less than 1. So this is 1A over E. So that gives you the equation of axis. Do these calculations. The diagram is before you, and see what is the equation of this particular horizontal line. So I've kept this as an exercise for you. Now let's look into the next example. In this example, let's look into the equation first. Basically, we are given the equation, graph you need to draw, correct? Graph you need to draw. The equation is x squared over 36 plus y squared over 81 equals to 1. The example is that the major axis is vertical. We need to identify center, vertices, co-vertices, and the foci from the given equation, which is x squared over 36 plus y squared over 81 equals to 1. Now clearly, this is a standard form where the center is at 0, 0. Square rooting the denominators, we get the value of a and b, right? So you can see that a is square root of 36, which is equal to 6, and b is square root of 81, which is equal to 9. Now in this case, b is greater than a, and therefore we have a situation where the major axis is vertical, right? So the major axis lies here. So this is your major axis. The distance is now square root of b is 9. So it is 9 plus 9, as you can see. So that is what it is. So major axis length is 18, as you can clearly see here. On the other hand, the minor axis is 6 and 6. So the minor axis length is 12. Perfect. So we do get vertices, and this time it will be on the major axis. That means vertical. So all these parameters are on the major axis, which is vertical. So we can now find, starting from the center C, which is at the origin, adding A, we get the vertices. You get the idea? Adding A, we get the vertices. So this is at A and that is at minus A. So we get the vertex, which is in this case 0, 9 and minus 9. The co-vertices are along the x-axis this time, the minor axis. So the co-vertices are at plus and minus 6 as given here. Next thing which you have to do is find the value of c, which is square root the difference between the denominators, b square minus a square this time. And so you get 81 minus 36, which is 3 square root 5. So in general, what you need to do is to find the value of c. You can always write c as equal to square root of absolute value of a square minus b square. You get the idea. Within the square root, it is always positive, and therefore to find the value of c, you can have difference of these denominators, absolute value, and then you square root, you get the value of c, which in this case is 3 square root 5. And therefore, you know that this distance from here to here is 3 square root 5. You get the idea. Since this distance is 3 square root 5, the foci is at plus or minus 3 square root 5, since they will be c distance away. So this is what we call c, small c, distance away from the origin. So finding the origin and getting all the points is the best thing to do whenever we're talking about the characteristics or the graph or the parameters of an ellipse. I hope this point is absolutely clear. So we get the foci, which is at plus and minus 3 square root 5 along the y-axis, so x value being 0 as shown here. So I hope these points are absolutely clear, right? We'll also have practice questions for you as shown here. So you can see these practice questions and answer them now. So for example, if I take up this particular question, how will you approach? Well, you know the value. Here we have x square over, let me write down here, we have x square over 16 plus y square over 25 equals to 1. First thing first, which is greater? Well, b is greater than a. And therefore, we can now sketch our ellipse in this particular direction. Do you get an idea? Perfect. So that becomes our ellipse. B is greater than A. Since we know it is a standard equation, we know that the graph should be kind of like this. So as soon as you see the equation, sketch your graph. And now you know the value of A and B. So what are these values? Well, vertical axis is the major axis. Mark those points. We know this is center is at origin itself. B is 25. Square root of 25 is 5. So we get plus and minus 5 as the vertices. So in this case, the vertices are at x value being 0, right? 0 and plus and minus 5. So those are along the major axis. As far as the co-vertices are concerned, let me change the ink now for the co-vertices. Well, the co-vertices are along the x-axis, and this value is minus a, that value is plus a. So the co-vertices will be they are along the x-axis, so plus minus a comma 0. Perfect. That is how you get it. Next point to look into is the focal point. How do you get the focal point? Well, to get the focal point, we have to calculate what is C equals to. C is absolute value of difference between the two. So you can write this as, well, better to write a bigger number first when you want to do the difference, and then you can square root it, right? So that gives you square root of 9, which is plus and minus when you square root it, and you get this value of, well, for C, we always take the positive value. For the focus, we'll do plus and minus. Square root is always positive, correct? So that gives you square root of 9, which is 3. And that gives you the focal point F, which is always along the major axis. So the major axis is the y-axis. Therefore, the two foci will be at 3 units from this center, as you can see very clearly. So 0 plus 3 and 0 minus 3 will give you the focal point. Is that clear to you? That is how we are going to do this particular question. So I hope the approach is absolutely clear. With this approach, let's now continue with the transformed form. Correct? So now I'll take up the examples where we will look into the transformation of an ellipse. That is to say, now the ellipse has moved from its original position with center at 0. So the figure here is actually showing that the original was at with center at 0 has moved 2 units to the right and 1 unit down, correct? So when it moves like this, what happens? Translation, right? So the standard equation, we will move x 2 units right. So x squared terms becomes x minus 2 whole square, right? So what is really happening is that when you use 2 units right, so the numerator now becomes x minus 2 whole square. Well, the a value is how many units away the center is from the vertex. That is given to us as 16. But the important thing here is about translation, moving 1 unit down. So when I move 1 unit down, the y value will be minus of minus 1. So that will be y plus 1 whole square over whatever it was originally, 3 in this particular case. So in this particular example, 3 square. In this particular example, this point was at 3 and this point was at minus 4. So those gives you a and b values, correct? Now here we have a translated version shown in red. So as shown here, this ellipse here has been translated. It has been moved 2 units to the right, 1 unit to the bottom, left, down, and that gives you a transformed equation, correct? So in general, you can write the transformation as x minus h whole square divided by a square plus y minus k whole square divided by b square equals to 1, right? So the diagram shown is for a greater than b. Therefore, I'm writing it on this side. I hope this concept of transformation is clear to you. It is very similar to what we did in circles, right? So similar to circles. So the approach is exactly same. The only difference in circles and ellipse, as far as the equation goes, in circle, what do you have? A equals to B. Do you see that? In circles, A and B are equal, but in ellipse, they are not equal. So we can also say circle and ellipse, how are they equivalent? Ellipse is a special circle where A is not equal to B. Is that correct? Okay, so you can see one condition of ellipse could be that A is equal to B. In that case, ellipse approaches a circle, right? When A approaches B, or when A equals to B, it is a circle itself. So circle can be considered as an ellipse, right? But we keep it kind of different. Okay, so ellipse we say when A is not equal to B. However, as A approaches B, the ellipse approaches a circle. This is very important concept which I have brought in right here. Correct? Formation of equation and the transformation concepts are similar to what you did for other functions including parabolas. Okay, now here the center has been moved to h and k. That really means that the numerator will be translated positions h and k respectively, and therefore we have this translated equation of an ellipse. So I hope that is absolutely clear. Now clearly what else we see? All those critical points also move h and k distance away depending on where they are. Correct? So in this particular case, if the points lie horizontally, only thing which is going to change is the h values will get added if it is moving, and therefore we have our standard formula changed to the image points, right? Think like an image point now, right? So we have image point with a translation. So the translation is h right and k up. With that translation, we get all the formula. Correct. So the vertices, we are now considering the major axis being the horizontal axis. So in that case, as far as the vertex is concerned, it moves h units right, and therefore we will add the value of h to A. So this point has actually shifted right by h unit, correct? And therefore, the vertex will be at h plus or minus A, whether it was left or right. So both have moved the same unit to the right. So that is the whole idea, correct? So that is what has happened to the vertex when h is applied. As far as the co-vertex is concerned, it varies vertically, and therefore in that case we are adding or subtracting the k value to the y value. Makes sense, right? And respectively you can see that the major axis and the minor axis, instead of being at 0 0, they are now at h and k respectively as shown here. The distance will of course remain unchanged because what you get is a congruent figure, right? So the shape will be maintained, all the distances will be maintained, right? Focus, again, the value of C has to be added with H. Horizontal translation is very critical since we are looking at the major axis. And from that C, we get the value of the focus point, which is H plus AE or H plus C. So we'll prefer you to use H plus C formula. That is better. Eccentricity, once you find C, you can always calculate, and we know eccentricity E will be equal to C over A, correct? And the equation will be of the directrix, which will be moving also with these plus minus A over E. So I hope these equations are absolutely clear. The concept is the point which was xy now has been translated, and what we get here is x plus h and y plus k after the translation, And that is simple as that to remember to get all the points. Perfect. Let's take an example to clarify all this. So in our example, the equation is x minus 2 whole square over 16 y plus 1 whole square over 9 equals to 1. The graph being same as shown earlier. So we will now look at this particular equation and find all the parameters. Well, clearly we know the value of a is equal to square root of 16, which is 4. B is square root of 9, which is 3. A is greater than B, so major axis is horizontal, right? And the total distance is 2A, right? So this is like 4 units here and 4 units there. Now, the centers can be seen from the above. We know the center is translation 2 units to the right and 1 unit down. So that is the value of C, the translation. So the points basically which were x and y will now be translated, and what we get here is x plus h and y plus k to the standard equation. So that becomes a translation. So clearly, we can begin with the center itself, writing down the center points from the translated values. And what we get here is that the center is 2 minus 1. Since it was translated 2 units right and 1 unit down. The value of a and b, as we just calculated, is 4 and 3. We also see that a is greater than b, and therefore the major axis is along the x-axis. Vertex will lie on this. Co-vertex on the vertical. Right. So as far as vertices are concerned, we will add the translation factor to the denominator 4. So 2 plus 4 gives us 6, and 2 minus 4 gives us minus 2. So we get these two x's in the translated figure, right? So we know that now the center has moved. Center has moved 2 units right and 1 unit down. So the axis now is right here. Correct? So we have found that the vertices are here. So those are the vertices which are at 6 and at minus 2. Correct? So this value here is at 6 and this value here is at minus 2. So those are the two vertices. The co-vertices have also moved down by 2 units, which can now be found by checking the value on the y, right? So the x value being at 2, the y value is, will add and subtract the translation of 1 unit. So minus 1 plus 3, minus 1 minus 3. So this point comes at minus 4 and the other point which is at 2 now. You get the idea. So that becomes the co-vertices. Now let us find the focal point. To find the focal point, find the difference between the denominator, square root it, you get square root of 7. So now, translation of 2 units to the right means adding 2 to square root of 7 to get these points, right? So that is what you do, and subtracting square root of 7 gives you the focal points. So these are the two focal points for the given ellipse. So we get the value right there. So I hope these steps are absolutely clear, correct? So that is how you're going to do it. You can also find the eccentricity E, which will be what? The ratio of C, which is square root of 7, over the major axis A, which is 4. So that is the value of E. And to find the equation of directrix, which is a vertical line, it is x equals to E a over E, right? So let me write A over E. So A over E. So when you do A over E, you can find that the value is A is, in this case, A is 4, right? So 4 over this flips, right? So we have square root of 7 times 4. So 16 over square root of 7. So we get this equation for the directrix equation. So that is how you can calculate the value for the vertical line, which in this case will be here, right? Okay, so that completes our examples based on what we have learned. So we have seen the standard form and the transform form. Now let us do some reverse calculation. Here is the last example for you. We'll do the reverse calculation. This time, given the parameters, we'll find the equation of the ellipse, and then you may sketch the ellipse also. The question here is example 4, reverse calculations. Use the information to write the equation of the ellipse. Vertices 6 minus 6 minus 10 minus 6, and the foci is f minus 2 plus square root 7 minus 6, or minus 2 minus square root 7 minus 6. Now what do you notice? Well, we can actually kind of plot simultaneously and get the situation. If you look at the vertices which are at 6, the y value is minus 6. You get the idea. So vertices are at 6 and minus 6. So if I plot this point, which will be where? Minus 10 and minus 6, minus 6, minus 6. Let us say this is minus 10 and that is minus 6. And the other one is at 6 and minus 6. So we get these 2 points of the vertices. So let's call them V1, V left, and V right, right? So this is V left, V right. So clearly, we do have a major axis which is along this line. So that is the major axis. The equation of major axis is y value, which is y equals to minus 6, correct? So it also means that the standard equation, which was x square over a square, has been now changed. It has been translated. So we'll write the general equation, which is x minus h whole square over a square plus y minus k whole square over b square equals to 1. And this translation, as you can see, is vertical y minus 6. So from 0, it has moved 6 units down. So it means what? It means that the value of k is equal to minus 6. Is this part clear to you? Correct? So we got this part. Now, let's look into the translation on the horizontal side. Well, as you can see here, let me change the color here. This is at minus 10 and this point is at 6. So find the midpoint of these. So the midpoint will be where? That will give you the h value, correct? So the midpoint h and k we already have. So the center will be somewhere here. We need to figure out what is this point. So the center will be at h. So the h value, x value centers will be minus 10 plus 6 divided by 2. That gives you minus 4 divided by 2, or minus 2. So we have the h value which is at minus 2. You get the idea. So we have found the k and h value in this particular case. Now, how do we find the denominators a square and b square? Well, the value of a is half the length. So the total length is how much? Well, we found that this distance is 16. So half the length is, we know 2a is 16. So the value of a is 16 by 2, which is 8. Correct? So the value of A is 8. So we know that. How do we find B? Well, from the focus, we can find the value of B. Now the question is, how do we find the value of b? From the focus, we can find the value of b. So let us analyze the focal points. So one point is given to us as -2 plus square root 7, of course on the major axis, which is y equals to -6, and let's say this, and the other point is given to us as -2 minus square root 7, correct? And the focal point y value being still at -6. So that clearly indicates that the c value is square root of 7. And what is c? Well, c square is the difference of a square and b square. So that means b square should be equal to what? A square minus c square. So in this case, a square, we found the value of a as 8, so which is 8 square, and this is square root of 7 square. So we get what? 64 minus 7. So that is the value of b square. As far as b is concerned, b will be square root of 64 minus 7, and that is what? 57, correct? So b is square root of 57. So we get the values of a, b, and c, which is square root of 57, and now we have our equation. So the equation is x minus h, which is minus 2. It moved left by 2 units, correct? And so it will be written as x plus 2 whole square over the value of a square, which is 8 square, which is 64, plus y, and y has moved 6 units down, that is the k value, so it will be plus 6 whole square divided by square of b, which is 57, and all this is equal to 1. Is that clear to you? So that becomes the equation from the given condition. So that is how you can get all your points. And from here, we can actually sketch the ellipse, right? So b is square root of 57, which is more than 7, correct? So it is more than 7. So maybe somewhere it went down here. So maybe somewhere here and there, correct? And therefore, we can actually now also sketch the graph or the ellipse, correct? So the ellipse here is, like this. You can do a better diagram. Of course, the axis, let me erase this and do it again. So we have actually, they will be here, right? So above the axis, so that forms a better graph. This is the ellipse. So this is the major, this axis, and that is the minor axis, center being this point, correct? So that is how you can get the ellipse from the given condition. So I hope the steps are absolutely clear. Now let's end this video with some practice questions. I did one of them, which was question number 1 earlier. The other questions are for you to practice. Well, 1 to 4 are similar to the examples which we did. Question number 5 and 6. The standard equation is written in a different form. So what do you have to do here? Well, for these two questions, you need to complete the squares, correct? You need to complete squares, get them in this standard form, and then do it, right? In this form, right? And then do it. So that is what is required from you. In the next video, we will see how do we work with different forms of ellipse equation, and we'll learn much more. So I hope with this you have good idea of what ellipse is, how can we represent them, how can we find more about them, and how can we do the reverse calculation to find the equation from the given conditions. So that becomes a good foundation. From here, we'll now take up the next video where we'll see how do we master ellipse. Thank you for your time and all the best.